Nicole Sullivan. I'm actually a front-end engineer. I focus on CSS and front-end architecture and how to build scalable front-end architecture so that you can have sites with thousands of pages or millions of visits without putting as much strain on the system as you could in the worst-case scenario. I work together with the exceptional performance team, and now I'm consulting and doing open source projects centered around object-oriented CSS, which is kind of my baby. It was born out of a bet at Web Directions North, where somebody said to me, "It takes far too long. CSS is completely broken. I can't do an interface with it. It needs to be completely revamped as a technology because it's broken." And I said, you know what? I can write some CSS that would let you do, for example, the Google basic layout in 5 minutes. And he said, "Oh, okay, sorry. I talk with my hands. It's going to be a struggle." Yeah, he said that he had a lot of trouble building interfaces. I mean, I think it was a pretty typical situation. He's a developer, and he loves building really cool new apps and web products, but really hates the interface side. Feels like he plans out this much time for a project, and then the interface itself takes 10 times as much. How many people have built a web app? Okay, awesome. A website, obviously, everybody, I'd imagine. Has anybody felt that the interface part took way longer and was far more complex than what they expected? All right, yeah, I think that's very typical, but it doesn't need to actually be like that. The good news is that your CSS architecture has a big impact on the performance of your website. Overall, the HTML being stitched together and everything it takes to get all of that piece done is a really small portion of the overall performance picture. And when we start looking at CSS architecture, we can improve on the larger part, which is all the component download, all of this sort of junk that we stuff into our web pages. Okay, so the bad news is that as a front-end engineer, as a web developer, I can completely slow your site down to a crawl. No matter how perfect your databases are, no matter how wonderful your work has been, a little bit of bad choices on my end, and I can completely ruin your work. I can change it so that your users are seeing 5, 6, 7 second response times in an hour or so. Just a tiny bit of work for me will make a website slow down to a crawl if I don't do it correctly. There's a few things that we're doing wrong in CSS architecture right now, and in the way we're coding. Right now, you have to be an expert to even get started. You basically have to sit around coding alone by yourself for years before you're even useful to a web team. That's a problem. Every profession needs to have a way of sort of ramping up in a reasonable manner, and right now, CSS doesn't have that. In addition, our file sizes just keep getting bigger. As we add more pages or more functionality to our web apps, our CSS file size has this tendency to creep larger and larger and larger. As the site evolves, we continuously modify the CSS. We never get to a point where the CSS is relatively stable, and we're mostly just able to build cool new stuff with it. The other thing is that code reuse is almost non-existent. And it makes sense. People don't trust each other's code in the front end because the way that we're writing it, it behaves completely incorrectly. There's no consistency, there's no predictability. You take one module in one place and it behaves completely differently than if you put it somewhere else. As well, the code is completely fragile. So a web developer like me might come in, might code something really excellent for a website or web app, and then the first non-expert to touch it, and it's like a house of cards. It comes sort of tumbling to the ground. But these are things that we can actually fix. One of the most important mistakes that our front-end developers are making is that they're coding really, really clever modules. An amazing module, which in itself is perfect, but has no sense of the overall architecture of the site, doesn't fit in, doesn't reuse. The size of their CSS is going to increase in a pretty direct relationship with the sort of functionality that they have available. So I was talking with Douglas Crockford, and he said, JavaScript doesn't suck, you're just doing it wrong, or something relatively like that. And then he got on stage, and he said, CSS sucks, and we have to redo everything. We have to start over. Now, I think he's wrong. I think CSS doesn't suck. It has some limitations. It could be better. But I actually think it's a really powerful way of expressing what we want a website or web app to look like. But it's true, we are doing it wrong. First thing to think about is sort of complexity in CSS. It's natural to you all to think about complexity and to wonder how your solution is going to scale. It isn't necessarily natural to designers, and up until now, it's mainly been considered a design discipline. So if we wanted to calculate the complexity of a CSS solution, how would we go about doing that? All solutions are not created equal. It's a popular thing to say, there are lots of right ways to code something in CSS, but it's false. There are lots of wrong ways to code things in CSS, and if we start looking at the complexity of our solutions, we'll see which ones sort of rise to the top and which are actually not useful. The front-end architecture absolutely has to be right. Even best practices like spriting together images. Has everyone heard of CSS sprites? Okay, for those that haven't, it's the process of combining different background images into one larger image so that you have one HTTP request rather than multiple HTTP requests for each individual sort of decorative piece of the page. It's a really powerful tool, but used incorrectly, it can kind of go awry. And I don't mean to pick on Amazon here because, so that's their front page, and then if we keep going on a product page, there are more. So I don't mean to pick on Amazon at all because this is absolutely the case for a whole lot of websites out there. You start spriting, which is great. It's either combining background images, but then it gets bigger and bigger and bigger and sort of grows out of control. So let's sort it out. In what ways has the solution using CSS sprites introduced complexity? For one, in this case, they've chosen to have 4 HTTP requests instead of 1 for this particular module, which is blue border with rounded corner images. So that's 4 times as many HTTP requests as we really need. The next is going to be that there are 2 modules which are really similar. They both have your typical blue border, 1 pixel all the way around. They just have a different background image. But by combining their background image with their border, all of a sudden they've doubled the number of HTTP requests that they needed, and they've multiplied the CSS code because they aren't reusing any of the code behind this. There's also extra weight, because as the CSS sprite grows and it includes lots of different things, you'll notice that there are a couple of different images which both include the same icons. And that happens all the time. It's not that the sprite wasn't maintained properly, it's that we didn't sprite with a strategy. We didn't sprite objects that go together. We just sprited kind of everything in the kitchen sink into one sprite and then expected it to kind of basically stay reasonable through force of will, which isn't the best solution. The next is that there's extra weight because there's text included as images. Anytime you choose to use a font that isn't native to the web and you choose to use that as an image, what could be 1 gray button and 1 orange button, or maybe 2 or 3 of each for each of the different kinds, becomes multiplied by the different things that you'd like to say in that button. So using text as images is a really dangerous solution in front-end engineering. Extra dangerous as well because each of these buttons is going to require its own CSS, which means every time you add a new button to your site, you're adding more CSS, which is exactly what we want to avoid. There are 3 important metrics to pay attention to. The first is going to be HTTP requests. The next is going to be the size of your images. Sometimes having a larger image will reduce HTTP requests, but slightly increase the size of your site. So there are going to be trade-offs between these. But the goal is that with any solution, we're going to look at these 3 metrics and we're going to say, is this a good solution? Is this a proper engineering solution? Does it meet the criteria of a site that's going to be fast? So object-oriented CSS can help to do that. The goal is to create a component library of objects, sort of reusable Legos that you can mix and match to build pages. So you're trying to build a CSS that will allow you to do lots of different things, and then you combine them in unique ways so that you don't have a boring site or a web app. You have something that looks visually diverse and interesting, looks like that new cool thing that everyone's going to want to use. And yet, the components are being combined in really unique ways that mean that overall, the size of your CSS file is really small compared to the functionality that you get out of it. The first key is to separate the container and the content. This is something that people don't do, and it causes a lot of problems. If we have contour blocks, and we have background blocks, and we have content objects, if all of those are separate, and we can combine them any way we like, then that's super, super powerful. That means that we have the number of contour blocks times the number of background objects times the kinds of content we can put in it, functionality for this tiny amount of CSS. But if that blue border box, it always has to be with a mapped background, then all of a sudden you're sort of tying down your CSS and letting it only do a very narrow group of things. How do you extend objects? CSS isn't by nature an object-oriented language. You extend objects by adding multiple classes to an HTML element. It's something a lot of people aren't aware is possible. A simple example, this appears on every website in the known universe, I think. It's basically a fixed width media to the left, so an image, a flash, something like that, and some text to the right that's going to describe it. So it could be headings, it could be lists, it could be whatever. The text to the right is considered an open editable zone in object-oriented CSS. We're trying not to say what's going to go in there so that we can then include any of our objects in that zone. So the other object that happens pretty frequently is very similar. It's basically your same fixed width media, but instead of being to the left, it's off to the right. Now we could rewrite the code for this in two different ways and have two completely separate modules, but that doesn't make a lot of sense because they do actually share quite a bit of code. Instead, we can have a fixed HTML. So this is the HTML you'd have for that sort of thing, and you call it a media object. And the media object actually does the heavy lifting. That's the one that's going to make the fixed width media take the space it's supposed to take, makes the open editable zone take what's left, and then you extend it with media extended. So basically, media extended is something like a mix-in. It doesn't have a function in itself. It can only exist when applied to the media object. And it allows you to take that media object and say, yes, exactly like a media object, except my exception is that the fixed width media, the image or the flash, will be on the right now instead of on the left. The next bit is to separate structure from skin into two separate classes. This means that all of your structure objects, so it's going to solve all your browser bugs, all your little quirks that are going to be difficult to get around, all this sort of heavy lifting of CSS will be done in structure objects. That's going to make your modules, for example, have behave properly, have a head, body, and foot where they should, have position little presentational elements if you need to do rounded corners or something like that. So all that sort of heavy lifting, all the difficult stuff exists in the structure. And then the skins become super simple. So the goal of a skin is to make it pretty and to have every value in that skin be completely predictable, be something that you can calculate, not something that you need sort of a magician level ability in CSS to achieve. So this is an example of a skin. It would do sort of your ubiquitous gray rounded corner box, the very simple thing that exists on almost every site in the known universe. This isn't a lot of code. Basically, all I'm doing is setting a border. On browsers that support it, I'm using border radius so I can reduce the HTTP requests. Again, higher performance option. And then for IE that doesn't do border radius, I'm basically including a background image, which is my corners. Now you might be thinking, well, that's not nearly enough code to do a rounded corner box. Maybe you actually tried and failed or spent hours. Or maybe you've seen another example. But if you've separated out your structure from your skin, that's all you need because the structure is already on the object. The structure, everything that gets all the presentational elements where they need to be is already taken care of. Next important bit is to avoid location-dependent styles. This will be really important to keeping your CSS file size down. Right now, the standard procedure is to say, my weather module behaves like this, my other module behaves like that. But it means that your objects are completely unpredictable. So you might have a giant red heading, and if you copy and paste it over in another part of your site, it becomes tiny and blue. It's sort of like if you created a function to return the area, and every now and then, just sort of randomly, it returned the diameter instead. In any other kind of programming, that wouldn't make it past QA. But it's unfortunately the sort of standard way of doing things in CSS right now, and it's completely unacceptable. to me anyway. Basically, what you get when you write location-dependent styles is something like there was an old lady who swallowed a fly. Does everybody know that story? Basically, she swallows a fly, and then she swallows a spider to catch the fly, and then many, many other things up until a horse, and finally she dies. We're writing CSS just like that. We write one location-dependent rule, and then we realize, wait, in fact, we needed to be able to do the default thing there. So we overwrite the location-dependent to allow the default, and then overwrite the default to allow yet another location-dependent style. It's ridiculous. It's not scalable. It's not high performance. So this is what I'm talking about, and you'll probably see code like this. This is the best of what's out there, I think, in terms of code, because at least it's modular. At least we're sandboxing our modules and saying whether module looks like this or tabs look like that. The trouble is it's not enough. Basically, we've got a +1 for the modularity. It is better than it could be if it was just complete spaghetti code, but it's still broken. It still means that if you want that H3 that's in the weather module inside the tabs module, you can't have it. It's just not possible. You'll have to copy your CSS code again and double the size of the file or the size of that line each time you want to allow yet another functionality. Okay. How much time do I have left? Okay. 6 minutes. Okay. I'm going to do a quick demo. I think it's always easier to show it than tell it. So, okay, so this is a typical template in OOCSS. Now, you might be thinking, okay, template, head, left column, body, right column, footer. It's very typical, but what's different about OOCSS is that each part of it is independent. So basically, any object should control its own destiny. You shouldn't have some Uber class that affects objects way down in the cascade. So if I, for example, want to go in and change the way my template behaves, like for instance, the page by default has a 950 pixel width. If I want to have a fully liquid layout, all I do is add a class liquid to my page, and all of a sudden it's going to take whatever room is available in the browser, and you'll see now it would have resized. Additionally, the column should behave the same way. This came out of actually a discussion with Brad Newberg at Google, who said, I can't even do like the basic Gmail layout without spending hours and hours, and then it's still broken. And I said, well, yeah, absolutely you can. It's just that it's built wrong. So Gmail is a liquid layout, and if I want to extend the left column, I can go ahead and add a Gmail class to that. And straight away, it's going to take that really narrow left column view for Gmail. And then, actually, I don't think Gmail even has a right column, so let me go ahead and take that out. In order to take out part of this, part of the template, all you have to do is just remove it from the HTML. The goal is that each object, so your left column is an object, your right column is an object, all you should have to change in order to affect that object is something on that object itself. So if I want to change the width of the left column, all I should have to do is add a class to the left column. If I don't want a left column, all I should have to do is take it out of the HTML. It shouldn't be more complicated than that. More complicated makes it a lot harder to do CMS development, because we end up having to loop all through the DOM in order to get different parts to behave properly. Another thing, if you want to have two left columns, it shouldn't be more complicated than simply copying the left column and pasting a second one into the HTML. That's how easy it should be to get even a complex layout going. Same thing for grids. Basically, grids are ways of separating out a page into different sizes. So it can be, in my case, I use thirds. So it would be 1/3, 1/3, 1/3, or 2/3, or also all the fractions up into fifths. And so you can take these and you can paste them anywhere. And the goal is that each one of those grids should be completely independent, so that you can put it as a wrapper. You can use it to lay out your page, or within some specific place in your application. If you need to divide a space into thirds, it should be super easy to do that, or into any other bit. And if you want to change them, make it not be thirds, it should be a change just on that grid itself, not everywhere else. So there's a simple class that affects how that behaves. Basically, a size class, which is going to say how that should behave. So if I want it to be 1/4 instead of 1/3, I should just have to change one small class, and it should just change the behavior really simply. Additionally, for modules, basically what I did for modules is I separated out what is the structure. So we have a few different ways of building, for example, rounded corner modules and container modules, depending on what complexity you have. So you may need images for borders, or you may be able to get away with borders as borders. And depending on these choices, it will affect the performance of your page. So essentially, if you separate out what does the structure from what does the function, then you can combine them in different ways. So you can take, for example, a background block universe, and apply it to a block. So here I have my block, and you'll see mod is the class that does all the structure. Noted is the class that does that border, and then I can apply another class, universe, and I get a combination of those three. So straight away you get just a lot more functionality out of a lot less code. Okay, thank you very much, and look forward to